Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogba Jr., your math tutor. I am an instructor of mathematics at the University of Liberia. In today's lesson, which is a continuation of our previous lesson, we want to look at the proof of the exponential function with base a. So we want to look at the proof of the derivative of the exponential function with base a. So in previous lesson, we did the proof of the derivative of a natural exponential function, that is exponential function with base e. So in this case, now we want to look at base a. So base a can be numbers, like they can be like 2, like 10, like 5, like 6, and so forth. But with e, since e is a natural number, e was dealt with separately as a special case. So now, we want to find the proof, we want to derive the proof of the derivative of this particular function, y equals to a raised to the power x, where e represents 2, 3, 4, 5, 6, and so forth. Now remember that x is not equal to 0. So we can use the first principle of derivative. The first principle states that f prime of x is equals to the limit of f of x plus h minus f of x divided by h as h is approaching 0. So since this is y and y is the name of this function, and in this formula we have f, so we can rewrite this function by changing its name to f of x. So it's the same, nothing have changed. So this y has a new name, f of x is equals to a raised to the power x. So we know that f of x is equal to a raised to the power x, but we don't know what is f of x plus h. So f of x plus h was obtained by just replacing this x with x plus h. So we want to replace this x now with x plus h. So on this side, we must replace x with x plus h. So go to the problem. We have f prime of x is equals to the limit. This expression is just a raised to the power x plus h minus a raised to the power x divided by h as h approaches 0. Now we know from the standard limit that the limit of a raised to the power h minus 1 all over h as h is approaching 0 is just equal to log base e of e, log base e of this e that is here. So if this is b, it's log base e of b. If this is c, log base e of c, and so forth. So since we know this standard limit, we can rewrite this limit such that we'll be able to bring in the standard limit. So we have f prime of x is equal to the limit. Now we can rewrite this expression as a raised to the power x times a raised to the power h, because when the bases are the same, we can take one of the bases and add their powers, minus a raised to the power x divided by h as h is approaching 0. So we can now factor out the constant because a raised to the power x, a raised to the power x is common to the two terms and it is also a constant. So we can factor it out. We have f prime of x is equals to. So this a raised to the power x, we can just factor it out behind this limit. So we'll be left with a raised to the power h minus 1 divided by h as h is approaching 0. So what happens? This entire expression here is just, so a raised to the power x log base e of a. Now whenever the base of a logarithm is e, that is referred to as a natural logarithm. So this can be rewritten as a raised to the power x ln of a. So whenever we have y equals to a raised to the power x, where the coefficient of this x is 1, we're going to have the derivative to be e raised to the power x ln of a. Assuming you have y equals to 2 raised to the power x, the coefficient here is 1, so you just have y prime to be 2 raised to the power x ln of 2. Now, what if the coefficient of this is not not 1? What if the coefficient was something that we say probably is it's any real number that is not 1? Or what if this entire x was a function that is not just a linear function, right? It could be sine of x. It could be x squared plus 1. It could be 2 raised to the power x squared plus 3x plus 5. What if you had this kind of function? Then you cannot just say 2 raised to this expression, ln of 2. You don't say that. What we need to attach to it to make the answer to be correct is the derivative of this particular function. So in general, whenever you have to find the derivative of an exponential function with base a, so like we have y equals to a raised to the power, so let's say u in general. What if this exponent was u in general of function? Then y prime would just be equals to a raised to the power u times ln of a. Then we attach the derivative of this u. We say d by dx of u. So we are differentiating this particular u, right? So you can rewrite it as some books you will see a raised to the power u ln of a du by dx is still the same. Nothing have changed, right? So this is equal to y prime. So in our next lesson, we will solve a lot of problems on how we can find the derivative of an exponential function with base a. So thanks all so much for watching. Please don't forget to subscribe, to like, and to share. Thank you and see you in our next lecture.